Dear students, now we will solve a problem to calculate outlet temperature of the cold fluid and also LMTD calculation in case of heat exchanger using enthalpy balances. First we shall read the problem carefully. A heat exchanger has to cool 55,000 kg per hour of alcohol from 66 degrees centigrade to 40 degrees centigrade using 40,000 kg per hour of water entering at 5 degrees centigrade. Up to this, there are two fluids. One is hot fluid and the other is cold fluid. So here alcohol is hot fluid and water is cold fluid. So alcohol is flowing at 55,000 kg per hour flow rate and initial temperature of the hot fluid is 66 and it is dropped to 40 degrees centigrade because it lost its heat to water. Then here this cooling of this alcohol is done by water. So using 40,000 kg per hour of water flow rate is 40,000 kg per hour and water is entering at 5 degrees centigrade. Next, specific heat of alcohol Cp is given as 3.76 units kilojoules per kg per Kelvin and that of water, specific heat of water is also given. Calculate the outlet temperature of water. Here inlet temperature of water is given. We need to calculate outlet temperature of water and LMTD for counter flow and parallel flow. To calculate LMTD, we need all the four temperatures. Here already three temperatures are given. Fourth temperature we need to calculate, that is outlet temperature of water. Now, when we start the solution, the very first thing you need to write, that is for easy working out, is first identify which one is cold fluid and which one is hot fluid. First you write this one. Which one is cold fluid? Cold fluid is water and hot fluid, because the temperature is reducing from 66 to 40, cold fluid is alcohol. So first write like this. So whenever you say CpH like that, no, suppose you are writing, you want to write CpH, that means specific heat of hot fluid, that is specific heat of alcohol, or m dot H, that is mass flow rate of alcohol. Like that you can easily write. So now next is what? Now we will start writing this notation what is given. Mass flow rate of alcohol. Mass flow rate of alcohol. Alcohol is which fluid? Hot fluid. Alcohol is hot fluid. So mass flow rate of alcohol means what is the notation? M dot H. Okay, M dot H. H stands for hot fluid. Alcohol is the hot fluid. So what is the mass flow rate of alcohol? 55,000 kg per hour. Okay. Next, mass flow rate of water. Water is cold fluid here. So M dot C, that is 40,000 kg per hour of water. So 40,000, same units, kg per hour. Like this we need to write the given data first along with the notation. Next, what else is given? Entering temperature of alcohol is entering at 66, leaving at 40. So temperature of entering fluid, alcohol. Temperature of entering fluid. Entering fluid is alcohol. Yeah. Or alcohol entering temperature, whatever it is. So here, this is hot fluid, no? Alcohol is hot. So therefore it is THA. THA is 66 degrees centigrade. Then leaving temperature of alcohol. Leaving temperature of alcohol, that is THB, because alcohol is the hot fluid, leaving is B, so that is 40 degrees centigrade. Okay, next, entering temperature of water is given. Entering temperature of water. Water is here cold fluid. Water is cold fluid. Okay, so this is given by here TCA. How much it is? 5 degrees centigrade. Then leaving temperature. Calculate the outlet temperature of water. Leaving temperature of water is TCB. This is how much? That is your first question. Second part we calculate LMTD. In the first part, first we calculate TCB. So like this, we need to write first all the data given along with the notation. So depending on the data here what data is given? Heat capacities are given. Heat capacity also we can write. What is the heat capacity? Specific heat of alcohol. Specific heat of alcohol is given. Specific heat of alcohol is CpH. Alcohol is the hot fluid. What is its value? 3.76. 3.76 kilojoules per kg per Kelvin. Okay. Similarly, specific heat of water is CpC, because water is a cold fluid now here. So this is 4.18. Same units. Okay. So with this we wrote all the given data. Now, since specific heats are given CpH and CpC, energy balance equation we need to write is heat lost by hot fluid m dot h CpH into THA minus THB is equal to m dot C into CpC into TCB minus TCA. This is equal to Q here. This is the energy balance we need to take. Okay. So using this m dot h, we already wrote here everything in detail. M dot h is given, m dot c is given, CpH is given, CpC is given, THA given, THB given, TCA given, only TCB is the unknown. Just simple substitution, but you need to take care of the units. How to take care of the units is better write below this only, the units also. Then you will not do any mistake. So here we shall substitute the values. M dot h 55,000 here into CpH. CpH is 3.76 into THA is 66 minus 40. Okay, this is the substitution is equal to here 40,000 into 4.18 into what here? TCB, keep it TCB only, minus TCA. TCA is 5 degrees centigrade. Okay. So regarding the units here, you write kg per hour. This is. Are you substituting the correct values or not? Here units are okay, consistent. If not, you need to convert into the proper units. So CpH is 3.76. Sorry, this unit we will write. What is that? Kilojoules per kg per Kelvin into Kelvin. Like that. Why this is Kelvin or centigrade? Both are same. See here you are converting. But you are not showing, but you can show like this below that. You are converting 66 plus 273 and 40 plus 273. So Kelvin minus Kelvin, you will have Kelvin. Kelvin only. But here this minus, no, here. So this becomes minus 273. So this gets cancelled. That is why delta T is equal to centigrade or Kelvin. Value is same because you are adding and then you are subtracting. So here Kelvin, Kelvin, kg, kg. If you cancel out, you will have this whole thing in, this is Q, nothing but Q you will have in kilojoules per hour. After solving, if you want Q, here Q is not the question, but if you want Q, you can convert into joules per second, that you can represent in terms of watts. So you can calculate here also same units, so consistent everything. So solving, we will get TCB as 37.19 degrees centigrade. 37.19 degrees centigrade. Okay. So this is the outlet temperature of water. Outlet temperature of water, cold fluid, that is. Okay. So by writing the energy balance equation, we calculated outlet temperature of water. So the next question is how to calculate LMTD. Next question is calculation of LMTD. In that first bit we will do for parallel flow. First we shall write all TCA, TCB, then we will write parallel and counter. So what is TCA? 5 degrees centigrade. Okay. TCB 37.19 degrees centigrade. And THA is equal to how much? 66 degrees centigrade. And THB is equal to 40 degrees centigrade. Okay. We have all the 4 values. So we shall calculate. First A bit is for parallel flow. Parallel flow. How to calculate LMTD? LMTD is this. LMTD is delta T ln. Okay. LMTD is delta T ln. So delta T ln equal to delta T2 minus delta T1 by ln delta T2 by delta T1. Okay. This is how to calculate LMTD. Now for parallel flow, how to calculate we will see. First you write, here we will start. For parallel flow, we use two line diagram like this. First draw one arrow mark and name it TCA and TCB. This arrow mark direction shows the direction of cold fluid here. Entering is TCA, leaving is TCB. First draw cold fluid line. Then above that draw line for hot fluid. Now which flow contact we are discussing here? Parallel flow. So in case of parallel flow, where cold fluid is entering, hot fluid also enters in the same end. Okay, that is the parallel flow. That means both cold fluid and hot fluid enter at the same end of the exchanger. Okay, that is parallel flow or co-current contact. Both cold fluid and hot fluid enter at the same end of the exchanger and leave at the same end of the exchanger. This is parallel flow. So delta T1 is always at the entrance. That is fixed whether it is parallel flow or counter flow, delta T1 is always at the entrance, delta T2 is always at the exit. Okay. So in parallel flow, what is delta T1 now here? THA minus TCA. Delta T2 is equal to THB minus TCB. Okay. THA minus TCA, delta T1 here. Delta T1, THA minus delta T2, THB minus TCB. You have all the values. You simply substitute THA 66 minus TCA. TCA is 5. And THB 37.19 minus TCB is how much? TCB you got, THB is 40, THB is 40 minus TCB is 37.19. So this value is how much? Once you get delta T1 and delta T2, you can easily calculate delta T ln. And here 2.81 degree centigrade. I already explained you delta T1 whether centigrade or Kelvin both same only. Okay, value is same. You are adding and then subtracting. So delta T ln equal to delta T2 minus delta T1 divided by ln delta T2 by delta T1, that is equal to delta T2 is 2.81 minus 61 by ln 2.81 by 61. This you can take delta T1 minus delta T2 also, no problem. Anyway, you will get the same value. Because here negative is there, but here also you will get negative value. So both will become positive. So this value is 18.9. This is 18.9 degree centigrade. Here delta T2, delta T1 units gets cancelled. So delta T2 units, delta T1, that one is important. So centigrade or Kelvin both again same only here. Because you are adding 273 and subtracting 273. So this is delta T ln. We use like this, we represent like this, parallel. Okay, delta T ln parallel. This is how to calculate LMTD. These calculations are very important in the design of the heat exchangers. Okay, next, counter flow. Counter flow, calculation of delta T ln. Counter, we can represent like this. Okay, for this also use the same method. Two lines. First draw cold fluid line, that is let it be TCA and this is a TCB. Okay, next, because it is counter flow, when cold fluid is entering at this end, hot fluid enters in the opposite end. Okay, hot fluid enters here. So direction of cold fluid and hot fluid are opposite to each other. Cold fluid is entering here and hot fluid is entering in the opposite direction. Here cold fluid is entering here, hot fluid also is entering here. So this is THB. You can write off the values also here. That is THA is how much here? 66 degrees centigrade. And TCA, this is 5 degrees centigrade. And TCB is 37.19 degrees centigrade. And THB is what? 40 degrees centigrade. Like this you should draw the two lines. Is it clear? So cold fluid and then hot fluid. This is a counter flow, both opposite to each other. Now delta T1 is always at the entrance only. This is delta T1. And delta T2 is always at the exit. Like this we should write. So what is delta T1 now? Delta T1 equal to THB minus TCA. Earlier, in case of parallel flow, delta 1 equal to THA minus TCA. Here THB minus TCA. You need not by heart all the, just if you draw these two lines, it's very clearly, very easily you can write the expressions. So THB is 40 minus 5. That is 35 degrees centigrade. Delta T2 is equal to, here, delta T2, THA minus THA minus TCB. Okay, THA is how much? 66 degrees centigrade minus TCB is how much? 37.19. So this value is 28.81. 28.81. Therefore, delta T ln counter is equal to delta T2 minus delta T1 by ln delta T2 by delta T1. That is delta T2 is 28.81 minus 35 by ln 28.81 by 35. Here minus you are getting, here also you will get a minus. So its value is 31.8 degrees centigrade. Okay. So this is how to calculate LMTD for parallel and counter. And you can observe the concluding point. You can observe that delta T ln for counter is greater than delta T ln for counter is greater than delta T ln parallel. Okay, this is 31.8 and this is 18.9. Thank you.